Okay, so for our fourth example, so we have the integral of ln squared of x dx. So for this problem, obviously we don't need to make a choice of which part would be our u and which part would be our du, because we only have two parts. Now the ln squared of x and the dx. So obviously here directly we will have our u as ln squared of x, and then our dv would be simply dx. Okay, so our du is the differential of this. So applying the general power formula, so remember that ln squared of x is equal to ln of x squared. Okay, so therefore it will become 2 times ln of x raised to 2 minus 1, okay, times differential of u. So our u here is ln of x, so the differential of ln of x is dx over x. So our du would be 2 ln of x over x dx. Okay, and since our dv is x, so obviously our v is equal to x. Okay, so using the formula for integral by parts, so integral of integral of u dv is equal to uv minus integral of v du. So our u is ln squared of x, okay, times v, we have x, minus integral of v du. So our v is x, our du is 2 ln of x over x dx. Okay, so simplifying that would be equal to x ln squared of x minus, so we can cancel the x, and then taking out the 2 since it's a numerical coefficient. So 2 integral of ln of x dx. Okay, so since this part here still can't be integrated, then we can apply again integration by parts. So here our u again will be ln of x, therefore our du is dx over x, and our dv obviously will be dx, so therefore our v is integral of dx, so that is x. So continuing, so we have x ln squared of x minus 2, and then integral of ln x dx is uv, so our u is ln of x, our v is x, minus integral of v du, so x times dx over x. Okay, so simplifying, so we will have x ln squared of x minus 2, sorry, our v here should be x, okay, so x ln squared of x minus 2 times, this will become x ln of x minus, so cancel x, and then we will be left with integral of dx. So integral of dx obviously is x. Okay, so since we finished integrating, so plus c. Okay, so therefore our final answer, so if we remove this, so we can also have this as our final answer already, but if you want to remove the grouping sign and then distribute 2, so it's also okay. So x ln squared of x minus 2x ln of x plus distribute 2x plus c. Okay, so in integration by parts, so we can apply integration by parts twice or thrice until the integral part can be integrated using the fundamental formulas. Okay, so as you noticed here, okay, so in integration by parts, you can apply the integration by parts more than once. So in this case, in our problem, we apply the integration by parts twice. Okay, so first here, okay, and then the second part in here. Okay, so that is still okay. Okay, as long as you still group them, no, so that the numerical coefficient can be properly distributed. So for our final example, so we have here the integral of sine of ln of x dx. Okay, so notice that the ln of x is inside the trigonometric function of sine. Okay, so in this problem, so like problem number 4, we don't need to think about what would be our u, no, since we only have two functions, no, so the sine and then the dx. Okay, we only have two parts, I mean, so the trigonometric function sine and then the differential part dx. So by parts, so obviously our u would be sine of ln of x. Okay, so the differential du should be the differential of sine. Differential of sine is cosine, so therefore that's cosine of ln of x multiplied by the differential of the function inside the trigonometric function. So that would be differential of differential of ln of x is dx over x. So therefore our du is cosine of ln of x over again our du is cosine of ln of x over x dx. So our dv obviously is dx, so therefore our v is x. Okay, so rewriting, so you have the integral of sine of ln of x dx is equal to uv. So u is sine of ln of x multiplied by our v is x, so minus integral of v du. So our v is x and our du is, so our du there is cosine of ln of x over x dx. Okay, so as you can see, our x here will cancel, so therefore this will become so write first x, so x sine of ln of x minus integral of cosine of ln of x dx. Okay, so still we can't integrate this. Okay, so because we haven't discussed, no, so why we can't integrate this, because to apply the integral of sine, which is negative cosine, so notice here that the differential part should be the complete differential of ln of x. Okay, and then the complete differential of ln of x is dx over x. Okay, so here we only have dx, we don't have a denominator of x. Okay, so that's why we can't apply the fundamental integration formula for sine, so we need to integrate this by parts. So similarly here, so we still can't integrate this. So therefore, we can apply again another integration by parts. So where our u here is the cosine of ln of x, and then our du is similar with what we did here. So differential of cosine is negative sign, so we have negative sign of ln of x over x dx. Okay, and our dv is dx. Okay, this one. So therefore our v is x. Okay, so this will become x sine of ln of x, and then minus, so we can use curly braces because I think we'll be going to be using brackets later. So uv minus v du. So uv, so we have cosine of ln of x, v is x minus integral of v, and then du, and then du we have negative sine of ln of x over x dx. Okay, so we have here, so uv minus v du. Okay, so as you can see, we can cancel x here. Okay, and then therefore the integral of sine of ln of x dx is equal to, so rewriting x sine of ln of x, so minus, so this will become x cosine of ln of x, then negative, 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 so it will become negative integral of sine of ln of x dx. Okay, so as you can see, still the integral part can't be integrated. Similar with this and similar with the given. Okay, but as you noticed, so we have similar terms in the equation, so this and this, so we can transpose this other one to the other side and we can actually add them. So copying this, so this is integral of sine of ln of x dx. Transposing this, this will become plus integral of sine of ln of x dx, so that is equal to x sine of ln of x minus x cosine of ln of x. Okay, so since these are similar terms, so we can add them. So 1 plus 1, so this is equal to 2 integral of sine of ln of x dx is equal to x sine of ln of x minus x cosine of ln of x. Okay, so to eliminate, so since we are only looking for the integral of sine of ln of x dx, then we will divide both sides of the equation by 2. Okay, so that we can cancel this, and then what will remain is, this will be our answer. So the integral of sine of ln of x dx is equal to, so we can factor out the denominator 2, so we will have 1/2, and then sine of ln of x minus, sorry, so we forgot about the x, so let's just rewrite this. Okay, so erase it all. Okay, so I'm so sorry. So this will become, so factoring out 1/2, so 1/2. So this will be x sine of ln of x, okay, minus x cosine of ln of x, okay, plus c. Okay, so in this problem, so we have a persistent integral, no, that cannot be integrated. Okay, so what we did was, since the integral part was persistently recurring, okay, so it recurred again in here. So what we did is we just transposed it to the other side of the equation. Okay, so we can actually also do that. Okay, so with that we have finished the integration. Okay, so I hope you have learned something from this video, and then thank you for watching.